In the vast expanse of the cosmos, 635 light-years from our pale blue dot, lies Kepler-22b. This distant world, a super-Earth, orbits comfortably within the habitable zone of its star Kepler-22. Kepler-22b is about twice the size of Earth. It may be a rocky world with a molten core, or perhaps a gaseous giant shrouded in thick clouds. What secrets does this distant world hold? Could it be a new Earth teeming with life? Or does it harbor an alien landscape stranger than we can imagine? The discovery of Kepler-22b in 2011 sent ripples of excitement through the scientific community. Here was a planet larger than Earth, orbiting a star much like our Sun, at a distance that could allow for liquid water on its surface. The possibility of finding life, even in its simplest forms, on a world so similar to our own was tantalizing. But Kepler-22b remains an enigma, its true nature shrouded in the veil of interstellar distance. Is Kepler-22b a haven for life or a hostile alien world? To answer this question, we must delve deeper into the data we have, unraveling the secrets of its star, its climate, and the potential for life to take hold in this distant realm. Join us as we embark on a journey to Kepler-22b, a planet that holds the promise of answering one of humanity's oldest questions. Are we alone in the universe? Discovering planets around other stars, what we call exoplanets, is no easy feat. These distant worlds are incredibly faint compared to their host stars, like fireflies dancing around a spotlight. So how do we find them? Enter the Kepler Space Telescope, a marvel of engineering launched in 2009 with a singular mission to find Earth-like planets orbiting other stars. Kepler's success lies in its ingenious method of detection, the transit method. Imagine standing on Earth and watching a fly pass in front of a streetlight. You'd notice a slight dip in the light's intensity as the fly momentarily blocks a tiny portion of it. Kepler works on the same principle, but on a cosmic scale. When a planet passes in front of its host star, from our perspective, it causes a minute but detectable dip in the star's brightness. This dip, though tiny, is enough for Kepler to detect and confirm the presence of an orbiting planet. By carefully analyzing the duration and frequency of these dips, astronomers can determine the planet's size, orbital period, and even get a glimpse into the potential composition of its atmosphere. Kepler's observations revolutionized our understanding of exoplanets, revealing that planets are not the exception but the rule in our galaxy. Among its many discoveries, Kepler-22b stands out, a potential super-Earth orbiting within its star's habitable zone, a region where temperatures could allow for liquid water to exist on the planet's surface. Every planet is shaped by its star. It's the central engine that dictates climate, weather patterns, and ultimately the potential for life to arise. So, to understand Kepler-22b, we first need to understand its star, Kepler-22. Fortunately for us, Kepler-22 bears a striking resemblance to our very own Sun. Kepler-22 is a G-type main sequence star, just like our Sun. It's slightly smaller and cooler than our star, with a surface temperature of around 5,500 degrees Celsius compared to the Sun's 5,500 degrees Celsius. But don't let these subtle differences fool you. This slight temperature variation has significant implications for the habitable zone around Kepler-22. Since Kepler-22 is slightly cooler, its habitable zone is located closer to the star than ours. This means that Kepler-22b, despite orbiting its star in 290 Earth days, receives a comparable amount of energy to what Earth receives from the Sun. This similarity in energy input makes Kepler-22b a prime candidate for harboring liquid water on its surface, a crucial ingredient for life as we know it. However, the similarities between Kepler-22 and our Sun don't end there. Both stars have similar compositions, with Kepler-22 exhibiting a similar abundance of heavy elements. This similarity suggests that the planetary systems that formed around these stars might share common characteristics. further fueling the hope that Kepler-22b could be a world not too dissimilar from our own. Imagine a day that lasts for months, where the sun hangs motionless in the sky, baking the land below, or a world shrouded in perpetual darkness, its surface locked in an eternal frozen night. These are just two of the possible scenarios that could play out on Kepler-22b, depending on its rotation and the tilt of its axis. If Kepler-22b rotates rapidly like Earth, it could have a relatively moderate climate, with a more even distribution of heat across its surface. However, if its rotation is slow, or if it's tidally locked to its star, with one side always facing the star, the climate could be far more extreme. A tidally locked Kepler-22b would have a scorching hot day side, constantly bombarded by radiation from its star, and a frigid night side, locked in a perpetual deep freeze. The stark temperature difference between the two hemispheres could lead to violent storms and unpredictable weather patterns. The tilt of Kepler-22b's axis adds another layer of complexity. A tilted axis, like Earth's, could lead to seasons, albeit on a much grander scale due to the planet's longer orbital period. These seasons could drive dramatic changes in weather patterns, influencing the distribution of clouds, precipitation, and even the potential for ice caps to form at the poles. Section 5. Life in the balance from sunlight to perpetual night. The quest to understand Kepler-22b is ultimately a search for life. But where might life find a foothold on this distant world? The answer, as with all things related to Kepler-22b, is shrouded in uncertainty. However, by exploring different scenarios, we can begin to paint a picture of what life on this super-Earth might look like. If Kepler-22b is tidally locked, life might find refuge in the terminator zone, the narrow band between the scorching day side and the frozen night side. Here, temperatures could be more temperate, potentially allowing for liquid water to exist on the surface. Imagine creatures adapted to the dim twilight, their biology fine-tuned to thrive in this unique environment. On a rapidly rotating Kepler-22b with a more even climate, life could be far more widespread. Vast oceans could teem with alien life forms, while continents might be covered in lush vegetation, their colors adapted to absorb the light from Kepler-22. Imagine flying creatures soaring through alien skies, their wings catching the wind of a world that orbits a distant star. But life on Kepler-22b might not resemble anything we can imagine. Perhaps it's hidden beneath the surface, thriving in underground oceans or volcanic vents, shielded from the harsh conditions above. Or maybe life on this world has taken a completely different evolutionary path, resulting in creatures far stranger and more wonderful than anything we've ever dreamed of. Section 6. The pull of a new world, gravity's influence. Gravity is the silent sculptor of worlds, shaping mountains, carving canyons, and influencing the very evolution of life. On Kepler-22b, gravity is a force to be reckoned with, potentially shaping life in ways we can only begin to imagine. With a radius roughly twice that of Earth, Kepler-22b likely has a significantly stronger gravitational pull. This increased gravity would have a profound impact on the planet's environment and any life that might call it home. Imagine creatures with thicker bones and denser musculature, adapted to move under the weight of a heavier world. The increased gravity could also lead to a thicker atmosphere, trapping more heat and potentially creating a warmer climate overall. This denser atmosphere could scatter light in unique ways, painting the sky in hues unknown on Earth. Imagine sunsets on Kepler-22b, a kaleidoscope of colors unlike anything we've ever seen, but the influence of gravity extends beyond the physical. A stronger gravitational pull could affect the way life itself evolves on Kepler-22b. Perhaps life on this world is more robust, more resilient to the challenges posed by a more massive planet. Or maybe the increased gravity has led to entirely new forms of locomotion, shapes and sizes that defy our current understanding of biology. Section 7. A distant dream, colonization and human adaptation. The discovery of Kepler-22b ignited a spark of wonder in the hearts of many. Could this distant world, with its potential for liquid water and life, one day become a second home for humanity? While the challenges of interstellar travel remain immense, the dream of colonizing Kepler-22b is a tantalizing one. Imagine a future where humanity has mastered the art of interstellar travel, where starships ply the vast gulf between stars, carrying intrepid explorers to new worlds. Upon arriving at Kepler-22b, these pioneers would face a monumental task, transforming an alien world into a habitable home. The challenges of colonizing Kepler-22b are significant. The planet's gravity, atmosphere, and even the length of its day and night cycle could pose significant challenges to human health and well-being. Imagine the adaptations necessary for humans to thrive in a world with twice the gravity of Earth, or the psychological impact of living under a sun that barely moves in the sky. But despite these challenges, the human spirit of exploration and adaptation knows no bounds. Imagine domed cities, shielded from the elements, where humans could live and work, gradually terraforming the planet to make it more suitable for human life. Over generations, humanity might even adapt to the conditions on Kepler-22b, evolving into a new species uniquely suited to this alien world. Section 8. The echo of life. What does it mean to find it? The discovery of life beyond Earth, even microbial life, would be a watershed moment in human history. It would fundamentally alter our understanding of our place in the cosmos, proving that we are not alone in this vast and ancient universe. But what would it mean to find life on Kepler-22b, a world so distant and different from our own? The discovery of life on Kepler-22b would raise more questions than it answers. Is this life related to life on Earth, a sign of a common origin for all living things? Or did life arise independently on this distant world, a testament to the boundless creativity of the universe? Imagine the scientific discoveries that await us. By studying alien life, we could unlock new secrets of biology, chemistry, and even physics, potentially leading to breakthroughs in medicine, technology, and our understanding of the universe itself. But beyond the scientific implications, the discovery of extraterrestrial life would have profound philosophical and spiritual consequences. It would force us to confront our place in the grand scheme of things, to grapple with the implications of not being the sole intelligent species in the universe. Section 9. A universe of possibilities. As we stand on the precipice of new discoveries, Kepler-22b serves as a powerful reminder of the vastness and wonder of the universe. It is a symbol of the endless possibilities that await us among the stars, a beacon of hope that we may not be alone. While the true nature of Kepler-22b remains a mystery, its discovery has ignited our imaginations and fueled our desire to explore the cosmos. The search for life beyond Earth is a testament to the enduring human spirit of curiosity, our innate desire to unravel the secrets of the universe and understand our place within it. As we continue to explore the cosmos, we must remember that the universe is full of surprises. The answers we seek may not be the ones we expect, but they will undoubtedly be profound. Kepler-22b is just one small piece of the cosmic puzzle, a single world in a universe teeming with possibilities.